Greetings, M Squared here, and today we're going to talk about solving systems of linear equations. So there are three ways to solve systems of linear equations: graphing, substitution, and elimination. Today our focus is on graphing. But we need to know a little bit about what happens when we solve a system. First of all, a system of equations is just two or more lines. So if you're doing a linear system, it's just you have more than one equation. You're trying to find out where the equations intersect. That is our goal when we solve a system. Find out what point they intersect at. There's three options. There's no solution, one solution, or infinitely many solutions, and this is why. Here's a little graphic. So if you have one solution, that means the slopes are different and the lines actually intersect. I wanted you to see that there's two different lines, but notice these lines are exactly the same. That means they'd really be like on top of each other and you wouldn't even notice that the other one was there. And so they would intersect at every point. They would be on top of each other, so they would intersect at an infinite number of points. So that's when you get an infinite number of solutions. Here you get one solution. And then over here, notice that the slopes are the same, but the y-intercepts are different. That means they're parallel lines, and we don't have any solution. So that is what it's going to look like when you're graphing for those three cases of no solution, one solution, or an infinite number of solutions. So basically, the first step is to graph the lines and then write down the point of intersection. Remember, the answer is a point. So you want to make sure you write it as a point. So we've got slope-intercept form for this line. Okay, so we know that the slope is 1 and the y-intercept is -4. We've already graphed lines, so this is not, if you don't know how to graph a line, that's a different video. So I'm going to assume you know how to find the slope and the y-intercept, because y is alone, it's in slope-intercept form. So I'm just assuming that. So we've got a y-intercept of -4 and a slope of 1, so I just like to draw a bunch of dots because I want to see where the two dots are going to intersect. I'm going to use a different color on this. Now, if you notice that's in standard form and that the x and y-intercept would be 2, go for it. If you didn't, then you would subtract x from both sides to get it into slope-intercept form. And then you graph the y-intercept and you say the slope is -1. And so you go down 1 over 1, down 1 over 1. Now notice they intersected at a specific point. So I'm going to now connect the dots because it's a system of linear equations solved by graphing, so I need to make sure I actually graph the line, that I don't just leave it with a bunch of dots, because I need the lines. So what is the point? What is the answer? Where do they intersect? It looks like 3, -1. But to test that, I can always go back up here and check it. Here's my check. Does -1, that's y, equal 3, that's x, -4? Yes, that's true. And then check for this one. Does 3 plus -1 equal 2? Yes. So my check works. I am 100% sure this is my answer. So in this case, when I solve the systems, I got one answer, one solution. Okay, let's try this one. This one's in slope-intercept form, so I know my slope is -1. My y-intercept is -5. So I'm going to go down 5, and then I'm going to go up 1 over 1 a bunch of times. And then I'm going to grab this one, and I'm going to get y alone. This one didn't have a pretty x and y-intercept, so I'm just moving the -4 over, right? Subtract 4x from both sides. Doesn't combine with that, so this is my answer, or my equation, I should say, not the answer. And so my slope is -4, my y-intercept is -2, so I'm going to go here, and I'm going to say, oh, -4 slope, I'm going to go 1, 2, 3, I'm going to go down 4 and over 1. Oh, that would be positive. My apologies. I have to go down 4 in the other direction. 2, 3, 4 over 1. So ignore that little guy. And did you see where they intersect? Because they had the same point. So here we go. I've graphed both lines. Here's my solution, which is 1, 2, 3, 4, 5, 6. Looks like 1, -6. And then I'm going to test it. I'm going to say, does -6 equal -1 minus 5? Yes. And does 4 times 1 minus 6, which is that -6, equal -2? Yes, it does. Check, check. I know I'm right. That's my answer. Okay, so again, I'm graphing both lines. I'm checking to see what point they intersect at. Okay, this one, I could do my x and y intercept there, but sometimes, and that's fine, you could say, hey, your x, for those of you who know how to find your x-intercept is 3, y-intercept is, did I just say 3? X-intercept is 6, y-intercept is -3. But for those of you, let me tell you the advantage of getting it y alone. So let me get y alone. I'm going to subtract 3x from both sides. So I get -6y, watch that negative, because that's where a lot of people forget to put that little negative. So I just subtracted 3x from both sides, and that's what I got. Now I'm going to divide both sides by -6 to get y alone, because that tells me what the slope is. So now I know my slope is 1/2, and my y-intercept is -3. Now I'm going to do the same for this one. So I'm going to say x minus 3 equals 2y, and I'm going to divide by 2. And I get y. I'm just switching the order now. Y equals 1/2 x minus 3/2. Now here's the important part. What do you notice about the slope? The slope is 1/2 on both of them, and the y-intercepts are different. That means this is going to be a no solution. I already know that. However, when you solve by graphing, you better graph it. So let's graph this one first. 1, 2, 3, that's my y-intercept, and a slope of 1/2. So up 1 over 2. So I'm going to connect those dots in the middle in a minute. Now, if you don't like that, that is a -3/2. So 1/2, 2/2, 3/2. That's 3/2, and then you're going to go up 1 over 2, up 1 over 2. If you don't like that, you could actually make a t-chart, right? You got your x and your y. You put an x in, put a y in because x is alone. That's easier. You get 2 times 0 equals, plus 3 is 3. Put a 1 in. 2 times 1 is 2, plus 3 is 5. And you could just graph those 2 points. You could say 1, 2, 3, 0, and 5, 1. And that would be fine too. But the important part is that we noticed right away when we were manipulating those equations that they were parallel, so that we get no solution, because our answer is no solution. Okay, so right here we notice we have an equation without a y. So we have to remember that's when we get those horizontal and vertical lines, when we have no x or no y. So when we don't have a y, we just have an x, we go over to the x and we make a vertical line, because x has to equal -4 all the time. And this is what I'm always -4 from the y-axis, so that's that line. And then for this other line, I'm going to divide everything by 2 so I can get it in slope-intercept form. I'm going to switch that order just to make it how I'm used to seeing it, right? So I'm going to go down 6, 1, 2, 3, 4, 5, 6, and then I'm going to go up to left 1 until, keep doing that until I hit my line, and then I know where the point is. So here I'm at -4, +2. And so the check on this one's pretty easy for this line, because is x -4? Yep, okay, then this point is on that line. And then for this one, we just can plug in our x and our y, so we'd say 2 times y equals -12 minus 4 times x. And so our y was 2 and our x was -4. So this one gets me a -12 plus 16, which is 4, and 2 times 2 is 4. So we are for sure that that is correct. Sometimes you might mess up to get the wrong y-intercept. You might get the wrong slope. You might say it's negative slope instead of positive. There's a lot of little mistakes. So usually they don't try to trick you. If you're getting some weird kind of like 1.3, 5.7, at this level, they usually don't do that. So double check your slope, your positives, negatives, all of that fun stuff. Okay, let's get y alone here so we can get it in slope-intercept form. That'd be, if I divide everything by 4, that's 6/4, which changes into 3/2, minus 7. I want you to notice something about those two lines. Always notice, after you're done, I forgot my x, make sure you look at them. Those are exactly the same line. I already know what the answer is. That's an infinite number of solutions. So when I go over to graph it, I just have to graph the one line. But always pay attention to that, because if you do that, you'll save yourself a little time. So let's see, that's 7, so 10, 9, 8, 7. That's a 10 by 10 grid. That's how I can do that. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And I can just connect the dots. And I don't have to graph 2 lines. It would look the same if I graphed 2 lines. So my answer is infinite solutions. Okay, good luck with all that solving systems by graphing. M squared, signing out.